Hi everybody, today we are going to be adding and subtracting in bases other than 10. Now I know that this can seem a little daunting, but I think the problem for most people is that they try to learn an algorithm or they try to memorize steps without understanding the concrete model. And if you understand the concrete model first, then everything falls into place. So that's really what we're going to focus on today. We're going to be adding and subtracting in bases other than 10 using the concrete model. Here we go. So again, the easiest way to work with bases other than 10 is to use the concrete model, similar to what we did with the base 10 blocks. So let's review that first. Remember, we have units, longs, flats, and blocks. Now, a unit is always a unit, but the number of units in a long depends on what base you're in. If you're in base 10, like we are here, then a long contains 10 units. And then a flat is 10 longs. So, in other words, this is 10 to the 0, this is 10 to the first. This flat contains 10 to the second units, and then a block is 10 flats. So a block is 10 to the third units. And it's always 10 because we're in base 10. So 1, 10, 100, 1000. But we can have units, longs, flats, and blocks in any other base as well. And thinking in terms of the concrete model is going to let us only concentrate on the place value, and we won't have to keep mentally converting back to base 10. It really won't matter what the number is in base 10. Using the place value allows you to just stay in the base that your problem is written in. Now we're going to do some practice in base 5. So let's look at what the units, longs, flats, and blocks look like in base 5. So here's a unit. A unit is still just a unit. But now a long is not 10 blocks in a row. A long is 5 blocks in a row because we're in base 5. So this is a long. So a flat would be a square that's 5 units by 5 units. And then a block would be 5 flats. So you can see that that's going to be 5 by 5 by 5. Now let's write each of these in base 5. So this is a unit, so this is just 1 base 5. This is 1 long and no units, so we would write 1, 0 base 5. This is 1 flat and no longs and no units. So 1, 0, 0 base 5. You see how what we're used to calling the ones place, and I guess we still could, that's always the rightmost digit. And then next to that, because we work in base 10 all the time, we're used to calling this the tens place, but we're in base 5 now, so this is the fives place. Or you could say that this is 5 to the first. And then the next place that we're used to calling the hundreds place, this is the place where we put how many 5 to the second we have, or how many flats we have. And so a block would be written 1, 0, 0, 0. 1 block, or 1 5 to the third set of units. No flats, no longs, and no units. Remember, every time you write a number in a base other than 10, you must spell out using letters what base you're working in. Okay, so let's practice just a little bit. Now we're still in base 5 here, and you can tell that because my flat is 5 by 5, and this long is a set of 5 units, so we're definitely in base 5. So let's write each of these numbers. Here we have 3 flats and 2 longs and 2 units. So this number is 322 base 5. And then here in part B, we have 1 block, no flats. Now it's important that we preserve the place value, because if we can't know that the order of the digits goes from units to longs to flats to blocks, then none of this has any meaning. So we do need a 0 here to show that there are no flats. And then we have 3 longs and 2 units. And we know we're in base 5 because this long is made up of 5 units. And this block is 5 by 5 by 5. So we're going to practice adding and subtracting in base 5 by modeling the numbers with units, longs, flats, and blocks. And now just remember that as we go along, in base 5, if you have 5 of something, you must exchange that for 1 of the next place value. So what I mean by that is, like if you have 5 units, you need to exchange that for 1 long. If you have 5 longs, you need to exchange that for 1 flat, and so on. So let's take a look at the example 12 base 5 plus 31 base 5, and we're just going to model. So 12 would be modeled by 1 long and 2 units. 31 would be modeled by 3 longs and 1 unit. So here are all of our longs and units, and you can see that we have 1, 2, 3, 4 longs and 3 units. So now we know that 12 base 5 plus 31 base 5 is 43 base 5. 4 longs and 3 units. See how easy that is? And it's not intimidating at all if you can relate everything to units, longs, flats, and blocks. Now let's practice 43 base 5 plus 24 base 5. So 43 would be 4 longs and 3 units. 24 would be 2 longs and 4 units. Now here's where it gets interesting, because remember, we're in base 5, so we can't say that we have 6 longs and 7 units. We need to combine whatever we can combine, because we can't use any digits bigger than 4. If you had a digit bigger than 4, you would have 5 of something, and then that should be converted to the next place value. Let's start with the units. So here I see 1, 2, 3, 4, 5 units. Let's circle those, and we're going to combine those into 1 long. Now let me mark out these units that I've circled because I don't want to count them again. And now let's see, we have 1, 2, 3, 4, 5 longs here. So those longs are going to combine and make 1 flat. And now I'm going to mark out those longs. Now, these 5 longs made a flat. These 5 units made a long. But I still need to count this long in these 2 units. So let me just move those over here. And now let's see what we've got. We've got 1 flat, so that's 1. We've got 2 longs, so we put a 2, and then we've got 2 units, and then we label it base 5. So now we see that 43 base 5 plus 24 base 5 is equal to 122 base 5. Okay, now let's try 332 base 5 plus 143 base 5. So we start by drawing the units, longs, and flats that we need. So 332 would be 3 flats, 3 longs, and 2 units. And 143 would be 1 flat, 4 longs, and 3 units. And again, we're in base 5, so notice that a long is a 5 by 1 set of units, and a flat is a 5 by 5 set of units. And now let's see what we can combine. And I think it's a good idea to always start with the units and work your way across. It seems like the most efficient way to do it. So for units, we have 1, 2, 3, 4, 5. Well, those 5 could be combined into 1 long. So let me put a long there. And now we have 1, 2, 3, 4, 5 longs here. So I'm going to take these 5 longs and combine them into 1 flat. And now we have 1, 2, 3, 4, 5 flats. So I'm going to combine our 5 flats into 1 block. So we end up with 1 block and 3 longs, and let's write this number in base 5. Okay, so 1 block, no flats, 3 longs, and no units. See, you absolutely must be able to depend on the fact that the rightmost digit is the units, and then everything else falls into place. Units, longs, flats, blocks, and make sure and label it base 5. And so now we can see that 332 base 5 plus 143 base 5, when we get everything combined, ends up being 1030 base 5. Now let's try a subtraction problem. So here we have 421 base 5 minus 34 base 5. So we'll just start by modeling the 421. So that's going to be 4 flats, 2 longs and 1 unit. And now we need to take away 4 units and 3 longs. But notice that I don't have 4 units to take away, and I also don't have 3 longs to take away. So first let's deal with the units. What we need to do is get more units. So we are going to borrow one of the longs and break it into 5 units. So we're going to take that long right there and split it apart into 5 units. And let's go ahead while we're at it and get enough longs. So let's take one of our flats and let's split that flat apart into 5 longs. And now we will be able to take away 4 units and 3 longs. So I'm just going to mark them out here. There are the 4 units that we're taking away, and there are the 3 longs that we're taking away. And let's see what's left. What's left is 3 flats, 3 longs, and 2 units. And don't forget to label it base 5. So we see that 421 base 5 minus 34 base 5 equals 332 base 5. Now I want to do a couple more examples with you by drawing so that you'll know what your work might look like on the quiz when you have to draw this kind of thing in the show work window. How are you going to communicate to your instructor that you understand this concrete model? Well, here's how I would do it. So let's look at the example 1143 base 5 plus 431 base 5. And let's just draw our blocks, flats, longs, and units. Now you'll need to be a little careful so that your longs actually look like longs, but you don't have to like divide them up into 5 segments like the drawing had it on the last few slides. So here's what mine would look like. I would have one block, and see, it doesn't have to be fancy, just make it a 3-dimensional block. One flat, relatively square, 4 longs, and 3 units. Now, see, mine are not perfect, but just do your best. It's clear that a unit is not a long, and it's clear that a long is not a flat. So just make it easy to tell the difference between the pieces, and you should be fine. Okay, now let's go ahead and model our 431. So that's going to be 4 flats, 3 more longs, and 1 more unit. And I think it will be helpful if you go ahead and draw the second number in a different color, and that's easy to do in the show work window. And now let's see what we can combine. Well, we only have 4 units, so that doesn't need to be combined. But we do have more than 5 longs. So let's go ahead and draw a circle around 5 of the longs, and it doesn't matter which 5. And see, I'm just showing here that these 5 longs make a flat. And then you can go ahead and cross out those longs so it's not confusing to you, so it's clear that those have been used up. And now we have 1, 2, 3, 4, 5 flats. So those 5 flats together make a block. All right, now let's see what we have. We have 2 blocks, and we have 1 flat, we have 2 longs, and we have 4 units. So 1143 base 5 plus 431 base 5 equals 2124 base 5. And if I had to model the concrete model on a quiz, this is what I would draw. Let's try a subtraction one. So here we have 2103 base 5 minus 321 base 5. So this is going to be 2 blocks, 1 flat, no longs, and 3 units. And notice that I left a space here because I can see that this number does contain some longs, so I know that I'm going to need to end up with some longs here. So now what does it mean to subtract 321? Well, that just means that we need to take away 3 flats, 2 longs, and 1 unit. So you can see that we don't have enough flats to take away 3, and we don't have any longs, so how are we going to take away 2? And we do have enough units. We have 3 units, and we only need to take away 1. But now we kind of need to ask the question, when we start redistributing these things, do we need to start with the flats and work our way to the units? Or do we need to start with the units and work our way to the flats? And it doesn't really matter, like either way you're going to get the right answer. But I like to start with the larger unit and work my way down to the smaller ones because it's just more efficient that way. So I'm going to start with the 3 flats. Now I can see that I want to take away 3, but I only have 1. So I need to use one of my blocks to break that into flats. So I'm going to cross out this block, and remember a block is just 5 flats, so I'm going to separate that one block into 5 flats. And so that's okay now because I'm going to be able to take away 3 of those when I get ready to do the subtraction. Now I need to think about the longs. I don't have any longs, so I'm going to take one of these flats and break that into 5 longs. And again, somebody might say, well, how do you know 5? Well, because we're in base 5, so each flat contains 5 longs. All right, and now we have a unit, but we have enough units here to take away 1. Okay, let's go ahead and cross out the things we're taking away. So I need to take away 3 flats and 2 longs and 1 unit. And now our answer is whatever we have left. So the answer is 1 block, 2 flats, 3 longs, and 2 units, and we're in base 5. That's it. You see how you'll need to draw it when you're showing your work. The different colors help. See, I started in purple. I drew everything from the first number in purple, and you can choose any color, but I'm just saying the colors will help your instructor know what you're thinking. Then when I took something to break it apart to make smaller pieces, I did that in a different color. Then when I actually did the subtraction, I did that in another color. And that's not a mandatory thing, but I just think the color coding will kind of help your instructor know what you're thinking. Now, just to show you that you can do this with any base, I would like to do a couple more problems in base 8. So let's see what units, longs, flats, and blocks look like in base 8. Well, a unit is still just a unit, but now a long is an 8 by 1 set of units, and a flat is an 8 by 8 set of units, and of course a block is 8 by 8 by 8. So we still are going to be able to use place value. The only thing that's different is how we will combine pieces at the end, or how we will break larger things up into smaller things. Now, instead of combining 5 units to get a long, we'll combine 8 units to make a long and 8 longs to make a flat. See, that's because we're in base 8. So let's add 265 base 8 plus 367 base 8. Okay, 265 is 2 flats, 6 longs, and 5 units. And 367 is 3 flats, 6 longs, and 7 units. Now, you don't have to line them up this way, but I found it most convenient to line them up this way because then it was easy to circle things. So let's start with the units and see what we get. So we know that 8 of anything needs to be combined to make 1 of the next place value. Here I have 1, 2, 3, 4, 5, 6, 7, 8 units. So I'll just circle those, and I'm going to put those 8 units together and make a long. Now I want to cross these out so I don't accidentally use them again. And now let's see about our longs. So here we have 1, 2, 3, 4, 5, 6, 7, 8 longs, and I'm going to put these together to make 1 flat. Now you could pick any 8 longs, I just happened to pick this 8. So together they make 1 flat, and I want to cross out the ones that I've already used up. See, these 8 longs are now in this flat. And we only have 1, 2, 3, 4, 5, 6 flats, so not enough flats to make a block. And now let's see what our final answer is. We said 6 flats, 1, 2, 3, 4, 5 longs. See that one there? Don't miss that one. 1, 2, 3, 4, 5 longs, and 1, 2, 3, 4 units, and that's in base 8. Now, what would this be in base 10? I mean, I don't have any idea off the top of my head, and you see it does not matter. We don't have to worry about base 10 at all. That's what I love about doing the addition this way. And now let's look at a subtraction in base 8. So here we have 1273 base 8 minus 436 base 8, and let's just model it like we did before. So this would be one block, and remember now we're in base 8, so this block is an 8 by 8 by 8 set of units, even though we're not drawing all the little lines. And then this is 2 flats, so these flats are 8 by 8, and 7 longs, and then 3 units. And then we want to take away 4 flats, 3 longs, and 6 units. Now you can see that we don't have enough flats to take away 4. We have plenty of longs, but we don't have enough units to take away 6. So let's start over here and let's break apart our block so we can have enough flats to take away 4. So this is a base 8 block. So when I split this block apart into flats, it's going to make 8 flats. And now I need to be able to take away 3 longs, which that's fine. I have more than 3 longs here, but I need to be able to take away 6 units, and I don't have enough units. So I'm going to have to take one of my longs and split it up. Now how many units will I get from this long? Well, we're in base 8, so this long is going to make 8 units. Now we can go back and do the subtraction. So now I'm going to take away 4 of the flats. See that? How I used a different color to cross out the flats that I'm subtracting. And I'm going to take away 3 of the longs. So I'll just mark out those 3. And I'm going to take away 6 of the units. So 1, 2, 3, 4, 5, 6. And now let's see what's left. The answer to our subtraction problem is 6 flats, 3 longs, and 5 units, and we're in base 8. And there you go. This is how you do addition and subtraction in different bases using the concrete model. And now you can see that if you had to do this all the time, you would pretty easily be able to adapt this into an algorithm that would be easy to understand, but it will only be easy to understand if the concrete model makes sense to you first.